Hello, and welcome to Equations of Lines. This will be a college algebra view on this subject. If you need more detail about any of these things that I'm going to be starting with, check out the intermediate algebra lecture of probably a very similar name. So let's start with the forms of equations of lines that we already know. For a given slope m, a y-intercept b, and a point x1, y1, we have four different forms, and actually it's only three different forms, but we're going to call it four. The point slope form, y equals m times x minus x1 plus y1. And this point slope form number one comes from form number two that we're all more familiar with. It comes from it's a generalized version of the slope formula. Y minus y1 equals m times x minus x1. The point slope form of the equation of a line is what you'll use most frequently in calculus. So I use that heavily here in college algebra, whereas in intermediate algebra I would emphasize more of the slope-intercept form of y equals mx plus b. We also have the standard form, and it seems as though the standard form varies depending on which textbook you're using. And so I'm going to give you kind of a more general definition of this. Standard form of the equation of a line is ax plus by equals c, with a, b, and c constants, our x and y, our general variables here. A and b cannot both be 0, but in general, come on, use the pen here. There we go. A should be non-negative. And in fact, a, b, and c should be integers, not just any constants, but actually integers. And this is the best way to go about writing the standard form because it is more all-encompassing. All right, so let's do some examples. Let's find the point slope form of a line passing through the points 1, 2, and 3, negative 2. So we'll use point slope form number 1. Number 2. Let's use number 2. Using form 2, we find that we need to figure out our slope. In order to find the slope, we subtract the y values, and then we subtract the x values in the same order. Negative 2 minus 2, I need to write better 2's here, is negative 4. 3 minus 1 is 2. Negative 4 divided by 2 is a negative 2. Whew, that's a bad little 2 there. That's all right, we'll take it. Now, if my slope is negative 2, I'm going to use this point as my x1, y1 for two reasons. It's listed first. That's all I need. But also because it has smaller numbers and no negatives. So when I move on to form 2 here, y minus 2 equals negative 2, my slope, times x minus 1. And that's the point slope form of the equation of a line. We don't need to simplify to slope-intercept form until this next example when it tells us to. So we're going to find a point slope form of the line satisfying the conditions. So we have a slope, we're given a point. Then we're going to convert that equation to slope-intercept form and finally write it as a function. So first step, we'll do y minus 5 equals negative 12/5 times x minus 4. All right, so we found the point slope form. Close that parenthesis off. Now I'm going to distribute my negative 12/5 plus 48/5. Convert it to slope-intercept form, so let's finish that off by adding 5 to both sides. Keep in mind that when we're adding 5, I'm going to use a little side pen over here. We have 48/5. I do not use my side pen. Plus 5 over 1. There we go. We need a common denominator in order to add fractions. So this will be 48/5 plus 25/5, which feels very much like 73/5. And we have y equals negative 12/5 x plus 73/5. And to finish this off, we'll write it as a function of a line. F of x equals a negative 12/5 x plus 73/5. Now you and I both know the 73/5 could be written better. It could be written as a mixed number, but don't lie to yourselves. Mixed numbers are not always better. Mixed numbers are used for carpentry and baking. That's it. That's it. So when you are in this class, I prefer improper fractions, no mixed numbers. Ever. And that goes for your homework system too. You won't want to use mixed numbers, you'll use improper fractions. All right, so here in example 2, I'm given 2 different points, right? They're essentially 2 points. They happen to be the intercepts, but we can still find the slope. The slope is negative 3 minus 0 over 0 minus 4. This is negative 3 over negative 4, which is 3/4. So I also already know the y-intercept. So maybe I'll use form 1 from above. That was y equals m x minus x1 plus y1. Now, I realize I used the second point for my x1, y1, and the reason for that is because the 0 is nice, plus or minus, that's horrible. But we can find the equation quite quickly if we use that method. If instead we choose to use the other point, y minus 0 equals 3/4 x minus 4. This is an or. You do not have to do both. We'll see that we have the same answer either way. So whichever point you chose, you'll get the exact same answer. Let's finish this off with function notation. 3/4 x minus 3. All right, circle our answers. There we go. Moving on to the next page. Find the slope-intercept form for the line passing through -1, -4, and 1, 2. Always our first step is to find the slope. 2 minus a -4 over 1 minus a -1. Smart me might have switched the order of these, so I subtracted. I started with the negatives and subtracted, but that's all right. Because as we're subtracting negatives, it's still early in our lessons here. Let's not forget that subtracting a negative turns into addition. 2 plus 4 is 6. 1 plus 1 is 2. 6 over 2 is 3. Now, if we could use either of these points, we don't always have to use the first one. It doesn't always have to be x1, y1. It could be x2 and y2. See how the point 1, 2 looks easier to deal with than negatives? I'm going to use that. I'm going to use that and do y minus 2 equals 3 times x minus 1. Now I can distribute the 3, add 2 to both sides, and I'll write this top of the next column over here, y equals 3x minus 1. Slope and intercept, I know my slope is 3, I know my y-intercept is -1, so my y-intercept is the point 0, -1. All right, now how can this help us in what we like to call the real world? Real world actually does not take place inside a classroom. Classroom's supposed to prepare you for that. So how might we use these skills in a future career? As we're analyzing data, we find that in 2005, the average annual tuition and fees for attending a private college or university was $21,000. 10 years later, in 2015, this rose to $32,000. We can find the slope-intercept form of the line passing through these 2 points. And we can see what that means about the slope. So first, find the slope-intercept form of the line. First, slope. 32,000 minus 21,000 over 2015 minus 2005. Many times we'll say let t equal 0 correspond to a certain year, but we don't always scale our x-axes differently. Sometimes we just use the full year as well. 32,000 minus 21,000 is 11,000 over the course of 10 years. Plus, okay. When I divide by 10, I get $1,100. Keep in mind the top is dollars, the bottom is years. Dollars per year. And keeping this in mind, that your y value, the output, the y value is the top, so the units from the y value. The input value, the x, t, the time will be in years. And so that will give you the units. Whew, that was a hard word to come up with. The units for your slope. And it makes it easier to interpret your slope. So average annual tuition and fees for attending, I'm going to call these costs. Costs were increasing by $1,100 per year. Oh my goodness. There we go. Dollar sign. This is our interpretation. Notice the problem starts with words. It's all in words. So your answer should also be in words. Use the equation to estimate the cost of attending a private college in 2013. Oh, what? I didn't even find the equation. I've already interpreted this slope. Let's find this equation. I apologize. Y minus, I'm going to use the smaller values, 21,000 equals 1,100 times x minus 2005. It's always a good idea to read the instructions. Instructors do this just as often as students. We just forget to read the whole thing. Well, maybe not just as often as students, but pretty frequently. And I should be able to do this computation in my head, but I'm not going to leave it for my head. 2005 times 1,100. I'm glad I didn't. 22,05500. Woo! And when I add 21,000 to that, so I'm going to do negative answer, add to that the 21,000. I should end up with a negative 2,184,500. That's a big number. Let's see. In 2013, I'll get y equals 1,100 times 2013 minus 2,184,500. Now this number right here, this huge y-intercept, 2 million, that's why we generally scale back our x values. If our x value was a 5 instead, it's much easier to multiply 5 by that 1,100. Okay, so we have 1,100 times 2013 minus 2,184,500. And it seems as though tuition in 2013 would have been 29,800. And we'll write that in a horrible sentence because the problem started with words. We're going to end it with words. The tuition and fees in 2013 were $29,800. All right, and we have completed the problem. I'm going to go back real quick. Find the slope-intercept form of the line passing through. Okay. Interpret the slope. I did that right away. Use the equation to estimate the cost of attending in 2013. Okay, it looks like we've answered all the parts of this, so let's move on. Now we have a procedure here. In order to find intercepts, of any type of function, we set the opposite variable to 0 and solve. So to find any x-intercepts, we're going to let y be 0 and solve for x. To find y-intercepts, let x be 0, and solve for y. Let's take a look at this in several examples. Determine the x and y-intercepts on the graph of the equation. So here we see a standard form equation. We're going to graph it as well. So if I want my x-intercept, I'm going to let y be 0. And I call this Tuesday's cover-up method. I stole it from one of my undergraduate professors. It was called Craig's cover-up method. You see how we name things? But I stole it from him, so it's now Tuesday's cover-up method. If y is 0, notice my cursor, my arrow, is covering up the y because the 5 times 0 will be 0. It'll go away. And so we're left with 4x equals 20. Divide by 4, I get x equals 5. And this tells me specifically x is 5 when y is 0. I found the x-intercept. Similarly, we can find the y-intercept. The y-intercept, we set x equal to 0, and once again using Tuesday's cover-up method, this 4x is covered up, so I end up with negative 5y equals 20. It's covered up because if x is 0, 4 times 0 is 0. Divide both sides by negative 5, I'll get y equals negative 4. And again, we have x value 0, the y value is the negative 4. From here, we can graph 5 and negative 4. So 1, 2, 3, negative 4, 1, 2, 3, 4, 5. And do your best to make a straightish line. If you ever miss, you make the dot bigger. Life is all good. All right, so we're at 5, negative 4. Notice I did label this the negative 5, so I was one value above. Now, I've been doing a lot of talking. I encourage you to hit pause here as you try this problem on your own. Always feel free to click pause before I start a problem. That's the beauty of having a video lecture. So let's do the x-intercept, where y is 0. If y is 0, I'll have 4x equals 6. X equals 6/4, which is 3/2. So I know 1, 2, 3, 4, 3/2, that's 1.5 x value. My y-intercept, I'm not going to change colors this time. My y-intercept has an x value of 0. Minus 3y equals 6. So y equals negative 2. And that tells me right here, 1, 2, I'm at negative 2. I frequently label below that. I don't know why. Notice my line isn't all that straight. The system I'm using right now, I can't use a ruler to do it, but you know, close enough is good enough. We get the idea of the problem. All right, let's look at a word problem. The graph shows the amount of water in a 100-gallon tank after X minutes have elapsed. So we have the water in gallons and we have the time in minutes. Is water entering or leaving the tank? So let's see. At time 0, there's 100 gallons. 10 minutes later, there are 0 gallons, so it seems as though water will be leaving the tank. After 3 minutes, let's see if we could write on here, 2, 4, 6, 8, 20. Ooh, that's not 20, that's 25. 50, 75. All right, so at 3, we're looking about right here. This is just an estimate. I'm going to estimate that to be, what do you think? Maybe about 70 gallons? About, because this does not cross at an exact grid line. Anytime you have an estimate, your estimate, as long as it's pretty close, it should be correct. Find both the x and y intercepts. The x-intercept is at 10, 0, because I see the graph crosses at an x value of 10. My y-intercept is at 0, 100. Interpret, right? This is a word problem, so we have to understand what this means. So I'm going to talk about the x-intercept. After 10 minutes, no water remains. And let's use a different color so these don't run together. For the y value, the tank starts with 100 gallons. All right, that's where an x value of 0 is before we actually start letting it out. So we can find the slope-intercept form of the equation of the line. So let's do that. Let's find the slope first. Always, it's the first thing here, so let's find slope. Using these 2 points, I have 100 minus 0 over 0 minus 10. 100 over a negative 10 is negative 10. All right, so we're going to find the form of the equation of a line. Keep in mind, we have our y-intercept. Y equals negative 10x plus 100. But what does the slope of the line mean? All right, what is this slope? Interpret the slope. So negative 10, what are our units? So on the output, we have gallons of water. On the output, we have minutes. So the negative 10 gallons per minute means the tank is losing 10 gallons each minute. Whether it's being drained, it has a leak, it's coming out, we know that much for sure. So now we want to use the graph to estimate the x-coordinate of the point x comma 50 that lies on the line. So where's 50? Here's 50. I'm going to stick it in red here. 50. That looks like it's exactly half the time. We're going to say about x equals 5 minutes. And we could check it. If we put 5 in here for x, 5 times negative 10 is negative 50. Negative 50 plus 100 will give us our 50. So we could check it algebraically as well. This video is getting a little long, so I want to do just a couple more things. I believe these are the ends. This is the end. This is the last one. I'm going to break this video into 2 parts. Part 1, super long. Part 2, all about the calculator. All right, so definition. An equation of the horizontal line with y-intercept 0b is y equals b. An equation of the vertical line with x-intercept k comma 0 is x equals k. Now, find an equation of the line satisfying the given conditions. If possible, for each line, write a formula for a linear function whose graph is the line. So we're looking for a vertical line. Vertical lines are straight up and down. I have a vertical line through the point negative 5, 6. So here on my graph, negative 5, 6, it's going to be a vertical line. What I know is that x will always be negative 5. X will always be negative 5 because a vertical line has to be straight up and down. It has to be through the point negative 5, 6. And vertical lines don't care what the y value is. They never care about the y value. They're all selfish about themselves. As there is no y value present in this equation, we cannot write it as a linear function. Vertical lines, not functions. Similarly, a horizontal line, all right, a horizontal line passing through the point 2, negative 4. So I have my grid here, 2, negative 4, maybe that's there. And I have a line passing through. That line, a horizontal line, never cares what x is doing. It only cares what's up with y. So y equals negative 4, or the constant function f of x equals negative 4, because we can write this in function form. Both answers are correct. One, equation of a line. The second one, a linear function. Same idea. All right. We're almost there. All right, just give me 2 minutes. Let's see. For 2 non-vertical lines with slopes m1 and m2, that seems like a weird word to have there. They are. That's probably what I needed to say. The lines are parallel if and only if their slopes are equal, and perpendicular if and only if their slopes have a product of -1. Notice that that tells us here when m1 times m2 is -1, we also could divide both sides by m1 and find that m2 is -1 over m1. This is frequently given as a negative reciprocal or opposite sign reciprocal. All right, let's do last two examples. Here we go. Find the slope-intercept form for the line parallel to 3x plus 2y equals 12 passing through this given point. So if it's parallel to this line, my first step with this line, 3x plus 2y equals 12, is I'm going to solve for y. So I'm going to subtract 12x, and then I'll divide everything by 2. And I'm going to use this slope. Parallel, I know I want to use the same slope. So the value I use will be my m equals -3/2. And now I'll use the point given. So the point is 3, -5. If I'm given a point and a slope, I'm going to use the point slope form of the equation of a line. All right, so we'll have y minus a -5 equals a -3/2 times x minus 3. That's a y plus 5 equals -3/2 x plus, right? A negative times a negative is positive. 3/2 times 3 is 9/2. Let's subtract 5 from both sides. Take it up to the next column. We'll have y equals -3/2 x. Now we need to do this. 9/2. 9/2. Well, if it was 10/2, it'd be 5. So it looks like we're a half short of being the full 5. So it looks like we're short by a half. You could always verify that in your calculator. 9/2 minus 5. And we know how to put that into a fraction, but sometimes you never know when we need a little help. And it's all right to have a little help from your friend over here on the calculator. All right, last one. So it was longer than 2 minutes, my bad. Find the slope-intercept form for the line perpendicular to y equals -2x plus 3. So we're given a slope of -2. If I want it to be perpendicular, I will change the sign and flip the fraction over. So now I have a slope of a positive 1/2 and the given point, -2, 5, and I could once again write the point slope formula. There we go. Whew. Sometimes I can't talk while I write, or else I forget what I'm writing. It happens in real life, not just on recordings. And that's not a 3, so little puppy in the background. Got me thinking about playing with the pups. Okay, there we go. X minus -2 becomes x plus 2. I'm going to distribute that 1/2. Let's bring it up over here. 1/2 x. 1/2 of 2 will give us a positive 1. And when we add 5 to both sides, 1/2 x plus 6. Yep, just shy of 30 minutes. I like to keep these between 15 and 20. My bad, but it kind of all needed to be done at the same time. Stay tuned for part 2 of this video. It's going to be looking at linear regressions using our friend over here, the graphing calculator. Thanks for listening.